Okay, this problem here is a standard deviation problem. And the reason why I know it, there are two things. One, it talks about it being normally distribution. And two, it talks about a mean and a standard deviation. Those two things tell you you're doing a z-score problem. All right, so let's go to number one. They want us to sketch the diagram. So this is what you must have whenever you sketch a diagram. We're not doing that empirical rule stuff where we go 3 to the right and 3 to the left. No, we're not doing that. We're just sketching the diagram. So you do a bell curve. You draw the spine, which is the mean, which is the median. You label it. You get x is equal to the mean is equal to 55 and the standard deviation is equal to 7. Now what they want you to do is label for these particular weights. Okay, so I'm going to go to another color. And so the first one is 53. 53 is less than 55, so that's going to go here to the left. And it's going to go 53. 63 is to the right because it's greater than. And then 73. All right, that's what it is. Not that empirical rule stuff. That's the answer. Okay, now let's go down to B. They want us to find the probability that the egg is a medium. So I'm going to write my probability statement. Now it's really nice because they have the inequality written here for us. And medium is 53 is less than or equal to is weight is less than 63. Okay, now you know how I always like to draw the distribution, so I'm just going to sketch it off to the side, label the mean and the standard deviation, and 53, let me choose another color, 53 is less than, so that's going to be to the left, and 63 is greater than, and I'm going to shade in the middle. This is the area that they're interested in. So I'm going to go to my graphing calculator. Now, if you're on an Aspire, it doesn't matter whether you press probability or statistics, the distribution window is the same. If you're on a TI 83 or 84, you press second VARS, V-A-R-S, and you hit, that's the distribution window. Now we're going to go to number 2, normal CDF. Remember, we never use normal PDF. The C stands for cumulative. So we want to know about 53, 53.1, 53.2. We want to know about all those guys in between. So that's why we always choose CDF. Okay, so the first thing they ask us is our lower bound. That's 53. I get that from my sketch. My upper bound is 63. My mean is 57. And my standard deviation is 7. And I get 0.4859. So I'm going to write 48.6%. Okay? All right, so now let's go do the extra large. Well, here's the extra large. Again, I'm going to draw my distribution. All right, and so here's my distribution. I'm going to draw my bell curve, label my mean, label my standard deviation, and I want to know about 73. So 73 is greater than 75, and right, it's extra large, correct? Okay, and then I'm going to shade this way. Okay, so now I'm going to write my inequality statement. So the probability that my weight is greater than or equal to 73. Okay, so now let's go back to that window, the distribution window. And do you see my lower bound is 73 and my upper bound is infinity. So just type in a really big number. All right, and then 55 and 7 for your mean and standard deviation. And I get 0.005. Or if you want to write it as a decimal, you can say 0.5%, okay? Okay, I'm going to go to the next page to do C. Okay, now it says here, there is a probability that 0.3, that 30% of the random eggs have more than a weight of W grams. Okay, so again, you got to sketch. Makes it so much easier. All right, so my mean is equal to 55. My standard deviation is equal to 7. Now, remember that the mean is the median. So the median is 50%, so 0.3 is going to be less than. Remember also that the area underneath the curve is always 1. So here is 0.3. Now we put the area above the curve. Okay, now they said more than, so we're going this way. So how much of the curve did I shade? Right, I shade 70%. All right, so let's go write my probability statement. The probability that my weight is greater than something that I have to find is equal to 0.3. Now this is what I'm solving for. So this time, since I'm going backwards, I'm going to distributions, but now I'm going to go to inverse. Now, I'm not going to put in 0.3. How much of my curve did I shade? 0.7. And then my mean is 55, and my standard deviation is 7. And I get W is equal to 58.7. Don't forget your units, grams. Okay? Okay, so here they're talking about large eggs is 0.121, the probability, and they produce 2,000 eggs each month. Calculate an estimate of the number of large eggs produced. Okay, so this is like finding the expected value. And you know how I always say to you, if you were to roll the die 60 times, how many times would you expect to get a 4? How many times would you expect to get a 4? So the probability of getting a 4 is 1 out of 6. You multiply it by the number of times we rolled the die, which was 60. And so the answer is 10. That's what we would expect. So it's just going to be the probability times the number of items. All right, so it's going to be 0.121 times 2,000. Just let me get out my calculator. And I get 242 eggs. Okay, don't forget units. Okay, let's go over here to E. Now we're talking about selling price, and the probability that produces a small egg is 0.388. Estimate the monthly income by selling 2,000 eggs, and give your answer to 2 decimal places because we're talking about selling. Okay, so what they want us to do is estimate about selling all these eggs. So we have the selling price. What I'm going to do is I'm going to write down the probability. So they tell us that the probability of a small egg is 388. We found the probability of selling a medium egg. What was that, 0.48? 0.485? The large egg, they told us 121, and an extra large was 0.00506. Okay, those were the probabilities. Now, they only gave us a small because that was the only one we didn't know. Don't think they only want us to do small, all right? So, estimate the cost. So, do you see that it's going to be, the selling price is, so it's going to be 2,000 times the probability times the cost. So first let's do it for the small. So it's going to be, so cost is going to equal to 2,000 times 0.388 times 0.3 plus 2,000 times 0.485 times 0.5 plus 2,000 times 0.121 times 0.65 plus 2,000 times 0.00506 times 0.8. All right, so what I did is I multiplied each one by the probability, 2,000 by the probability times the price. Okay, let me go and do this math. Okay, so as you can see that I wrote down the n times the probability times the cost for small, then medium, then large, and then extra large. And then I came over to the other side and I wrote down what each of these were worth, right? And if you add all of these up, I get 883.10, so it's dollars, right? So make sure that this is not that bad of a problem, you guys. I have full faith that you guys can do this problem. It's just long.